And then I want to introduce A-frame properly. I have introduced it in the context of Glitch. So Glitch is our IDE. It's a site that hosts and allows us to create web content and see in real time what we've made, and then hosts it for us as web pages. It's very nice for what it is. A-Frame is totally different. It is a framework of HTML that wraps Three.js, a JavaScript library for addressing WebGL. WebGL is built-in graphics. In fact, it's a port of OpenGL, which is a graphics library. That's what GL stands for, graphics library. OpenGL is a graphics library that includes things like lights, cameras, um, um not physics, but things like particle effects, fog effects, and a bunch of primitives, which are geometric shapes. And WebGL is a port of that to the web, and it's built in natively to the web in something called HTML5. So none of that's terribly important at the moment. A-Frame addresses WebGL through a JavaScript library called Three.js, but it expresses it like HTML. So HTML is a markup language, not a coding language. But A-Frame allows us to create entities and attributes that make it very versatile and very much more like a programming language, but still fairly limited. But those limits make it very easy to use, very simple. Children can use A-Frame. This is the A-Frame IO, the website of A-Frame. Mostly we're concerned here with the documentation, the docs. So you might as well just bookmark this page. It's the A-Frame documentation. It's searchable. There is also a fairly long list of things you can learn about here. Notice that there are primitives here like a box, and those are created by this kind of tag, a hyphen box. A stands for A-frame, and all HTML is tagged like this. So this is basically an HTML tag with some attributes built into the tag, but we won't actually use that format much. We'll create entities and then we'll apply attributes directly to the entities. So, in fact, there should be an A entity here. D, E, F, G. No, okay, not so great. But we'll find other examples here. So, in fact, there's searchable. So here's geometry, and so if you want to make a circle, which is a flat object, or a sphere, which is a 3D object, or a torus, which is like a donut, or a ring, which is flat, like a flat donut. Boxes or planes, octahedrons, or torus knots. That maybe shouldn't be brown. Uh, this will show. This is much more the kind of format we'll use. A entity, and there's the end tag, and the attributes are built into the open tag, and they are geometry. So this entity could be a sphere or a torus knot, but it isn't. It's a primitive box, which is a cube. Width of 1, height of 1, depth of 1. And so you can copy and paste these things and create and paste them into your code and get boxes and whatnot. Then there are properties, width, height, and depth, and you see them here, but without declaring them, there are defaults, 1, 1, and 1. So if we don't use the width, height, and depth, we'll still end up with the same size box, 1, 1, and 1 by default. Then there's segment depths, which can be useful, and those are also defaulting to 1. And so there's the code, if you like, and that was from geometry. Then we might say material, And here we have a entity, geometry, primitive box, material equals, quote, color colon red. So again, the colons inside the quotes are equivalent to equal signs outside of the quotes. So this creates a box. It's 1 by 1 by 1 by default, even though it doesn't say that here. But the material is going to be red. Notice that this says red. It's not using the hexadecimal 6 socket alphanumeric. And you can use colors, a limited number of colors by name. And those you can find. So I'm just Googling named HTML colors. These are actually, here we go, HTML color names, 3W schools. That was my first result always, but here we go. 3W schools has a nice interface where you can see the color, get the name. Note that when you use the name linen, you won't use capitals, or light yellow, you won't use capitals. But you'll just write it just like that with no spaces. And you can have light yellow, and you can have, I don't know, 100? I don't know how many there are here. We could count them. It's 3 columns, and we could count the rows, and we'd have 1 extra. So we can have mint cream or misty rose, right? So those are named colors that you can use. 140. There we go. So those are also useful, and you can use those as well. But if you want something between aqua, white, and beige, and notice that here are the hexadecimals. You could start with aqua white and add some or subtract some to get it closer to beige. You get something between these colors, and now there are millions of colors, or certainly more than I can actually perceive the difference. So this is the documentation. It's searchable. There are showcases, communities where people answer questions. There's a GitHub where you can get the code. There's a Slack, a Discord. There's a newsletter. You can ask things. And then how to write your own components, because these are components, like the material is a component. And you can write your own components. And then, like I say, entity. Here we go, core API. So we have an entity, and entities have components. I said attributes earlier, but that's the same thing. Entities have components, and that gives us a lot of leeway. I also wanted to show like a position. So an entity's component can include a position. This entity has no appearance. It has no geometry associated with it, no materials, obviously, no nothing. But it does have a position, so it is a invisible numerical point, a mathematical point at this position. And those are useful because we can also do parent and child relationships, which we'll get into a little bit later. But that is an essential component or aspect of animation is parent-child relationships. So that if everything the parent does, the child has to do. So imagine I have an array or a bunch of objects, spheres, say, and they're arranged in a circle, and then I want that circle to rotate. I could put an entity at the center of that circle of spheres, and make it a parent, the parent of all the circle of spheres, and rotate the parent, which is invisible but does exist as an entity, and then all the spheres would rotate. And I also wanted to say scale. So scale, this is an entity with no appearance, no geometry, no color, no material, but it has a scale. And notice that although positions can be 0, 0, and 0 if we want, these aren't, but they can be. That would be the center of the space, 0x, 0y, and 0z. Scales default to 1, 1, and 1. because a 0 height is not going to be a visible amount of height. So keep in mind that 1 is not a measure of how tall the thing is in the scale. It's a proportion. So if I give, for instance, a cube or a box, if it is a 1, 1, and 1 height, width, and depth, I can still scale it at, say, 1, 10, and 1, and it will be 10 times taller, right? But the width and the depth will remain the same. But I can't, if I give it a 0, 0, and 0 scale, I won't see it. Right? So I'm not going to demonstrate these. I just wanted to show scale, position, and we've talked a little bit about material and color because your assignment will involve all of these.